Welcome to this session on generic dataset meta-analysis. By the end of this session, you should be able to conduct meta-analysis of fixed effect and random effect meta-analysis of generic dataset, be able to pull different types of generic datasets such as hazard ratio, standardized mean difference, as long as you have the effect size and the standard error, then be able to explore heterogeneity using subgroup and meta-regression analysis and be able to check whether there's evidence for small study effect, i.e. publication bias. We'll be using the following 5 steps that we've used before in the previous binary outcome. So for this meta-analysis, we'll be looking at this data from meta-analysis of exercise for depression. This particular study looked at the effect of exercise on depression outcome, and they reported the scale using the standardized mean difference between the intervention and control group. And we have additional variables that we are going to explore, such as whether this is an abstract or it was published as a full text article or not. And the duration of follow-up in weeks was also reported. Then they reported whether the study used intention to treat analysis or not, and whether there was adequate allocation consignment or not, and whether the study was published as a PhD thesis or not. So you can load this data set directly from the Excel, just copy it from the Excel onto this data set, or you can load them directly from this do file, but we are going to use the direct approach using save data set from this data format. So you first of all use this command use, unload the data set, and you describe it. These are the variables that I've mentioned before. Then the next step is to declare that this is a generic outcome, not binary, not a continuous one. So you let data know that for this meta-analysis we have the standardized mean difference and the associated standard error, and this is the study label, and I want to name it as standardized mean difference. Then the next step is to actually conduct the meta-analysis and summarize it in table or in forest plot. So the first question is, what are the summary estimates using both fixed and random effect meta-analysis, and is there any evidence of heterogeneity across these studies? So if we do the fixed effect, this is the result of fixed effect meta-analysis and that of the random effect meta-analysis. The pool estimates differs between the fixed effect and random effect meta-analysis. For the fixed effect is -1.01, while the random effect, the pool estimate, the 0.1 was -1.06. And the second question is that there's evidence of moderate substantial heterogeneity. This is moderate to substantial heterogeneity. This is almost 75%, and you can see the confidence interval does not really overlap across these studies. So the next step is to start exploring the heterogeneity using a subgroup in terms of the study type, intention to treat, allocation consignment, and whether it was published as a thesis or not. So we are going to do subgroup meta-analysis by abstract. As you can see, the pool estimate for those full text article is very low, where it's very high in those that reported in abstract, which shows, and if you look for the test of group difference, is highly significant. It shows that this effect may be overestimated among conference abstracts, whereas in study that were published as full text article, the magnitude of effect was lower than that of the abstract conference abstracts. In terms of whether the study used intention to treat or not, the estimate is there's no significant difference between the pool estimate group, and if you look at the p-value for the difference, is not significant. Also for allocation consignment, there's no significant difference between the two pool estimates. The same thing for whether this was published as a peer-reviewed citation or not, there's no significant difference in the pool effect estimate. So only the first variable abstract, there was significant difference between the pool estimate. So the next set of questions is, which of these variables are significantly associated with the pool estimate, and what percentage of heterogeneity is explained by this covariate. So we need meta-regression to do this. So let's go to Data to do this analysis now. So we first of all load the data set using direct method. It's in data folder. So data is now loaded. I can describe it. So these are the variable, then set or declare the variable, then to generate the forest plot fixed effect. There's the fixed effect forest plot. Then fix for the random. Let's close this down. Then we've done all this. So we can do this meta-regression, entering all these variables one by one, but we can use this loop command. So it shows that for each factor of this factor list, do this meta-regression analysis is the same as doing it one by one, but this is more concise and it's better coding approach. So if we look at all the variables, the meta-regression for the abstract is highly significant. The duration of treatment too is significant, but the ITT not significant, allocation consignment, the p-value not significant, then pH not significant. So to answer the question, abstract and duration of treatment, they were both significantly associated with the treatment effect estimate. So let's test for both of them together. So we enter the two variable meta-regression this and check how much variance did these two variables explain. So they are both still significant. As you can see, both variables explain all the heterogeneity between the study. It explains 100% of the heterogeneity, and the I-square is now 0%. So the differences we are observing across study were due to abstract, whether it was published conference abstract, and the duration of treatment. So the next task is to explore the effect of small study bias. We want to check whether there's evidence of publication bias or not. So how do we do that? We first of all look at the funnel plot, then do statistical test, Eger test, then do trim and fill whether there's some missing study that we could fill using the statistical approach. So first of all, we enter the command meta funnel, and as you can see, there's no evidence of publication bias. This is symmetrical. We have studied on both sides almost equally. So from the forest plot, we can say that there's no evidence of publication bias. Let's test it statistically using the Eger's test. If we look at the p-value again, it is not significant. It's greater than 0.05. Again, we say there's no evidence of publication bias. And lastly, let's try and fill this whether there are some hypothetical study that might have been missed. Again, look at this. The number of study, number of observed is 10, inputted 0. So we can conclude there's no evidence of publication bias in this particular meta-analysis. So we've sort of done 3 tests to check for the publication bias. We use the funnel plot, the statistical test, and the trim and fill. So we can conclude there's no evidence of publication bias. So in summary, we've conducted generic data meta-analysis using the following 5 steps, and we found there's no evidence of publication bias. So this brings us to the end of this particular section, and the next section we are going to look at the continuous data set meta-analysis. Thank you.